So let's try to get some energy to all of us here after lunch. It's not the easiest time to have a presentation, but I hope you will stay awake at least for this session again. So I will continue. I had the pleasure of saying good morning, and now I can say good afternoon. And if there are somebody who wasn't here, my name is Leni van Bonsdorf, and as Faten kindly told you, I'm representing the International Plasma and Fractionation Association. So in this presentation, I will go a little bit more into what IPFA is doing, and maybe a little bit more on the strategies that how you can build a plasma strategy for your country. So IPFA, International Plasma and Fractionation Association, we are an association, an international one, and we support the activities of not-for-profit organizations around the globe who are doing plasma collection and those who are also fractionating plasma into medicinal products. This is really, our focus is to enable a robust, safe, and equitable patient access to plasma-derived medicines. And we work a lot through education and services. We are quite a small association. You might know of the other association in the field. It's called PPTA. We are maybe the public sector representatives compared to them in this field. You can see from the map that we have members from around the world, and especially one has been mentioned here many times today is the National Bioproducts Institute in South Africa, who is the only fractionator on this African continent, and also a not-for-profit fractionator. The others are, many of them are plasma collecting enterprises, like in Lifeblood in Australia and in New Zealand and in Canada and in the US. They are all actually such enterprises who collect plasma for fractionation on a not-for-profit basis. So it's important to recognize that they are existing. So what I will be focusing on today is really what we have put as our objective. We want to support the public sector in every country in having a plasma strategy. This is a very short sentence, and it needs some explanation. And what we mean with plasma strategy is something that is really important. We think that a plasma strategy should be an integral part of a country's public health effort. And we want it to happen by strengthening the contribution and ability of the public sector to collect plasma in their communities and to find suitable ways to organize the fractionation of its plasma. Very much the topic of today's workshop as well. Because this way, countries and regions, we can also think about larger regions, not just a specific country, can increase the strategic independence of these vital medicines. And in a way which is really aligned with a wider public health policy and strategy. So let me explain a little bit more through this picture. I hope it will open up a little bit the explanation better. What is the role of the public sector in the plasma value chain? We like to explain this through the plasma value chain, which means you can see in the middle. It goes from the donor through plasma collection, through the fractionation, making the products. And here we have put payers of the plasma medicines. It could be providers of healthcare, but to give it a more economic aspect here, there's always somebody who has to really pay for the products before they get to the patient. And in the end, we have, of course, the patient needs. Above the plasma value chain, you see very much IPFA's values. We are very much keen on looking into donor health protection, that we are not any way exploiting donors in a way which is not good. And this is something that we really see that we can work through with our blood establishment connections. And of course, you wouldn't be interested in plasma-derived products if not patient health would be a main value and driver for it. Below the plasma value chain, you see these bubbles, and they are not exactly the correct sizes. They are more to illustrate that who is playing the larger part in these different sections. In plasma collection, we have already heard that a lot of plasma is collected in the US by the private sector. The plasma collected by the public sector globally is much smaller. Also, when we come to fractionation, mostly the fractionation is run by large pharmaceutical fractionation companies. And we have, like I explained, we have among our IPFA members some who are still not-for-profit enterprises, and there might be some overlapping activities as well. But when we come to the payers of plasma medicines, the public sector is very important. The countries, how they pay for their health care, how they pay for, reimburse for the medicines in their country. It can, of course, be private as well. You pay a part yourself, or you have insurances which cover it. That's another route. But let's say, when we talk about the unmet needs which have come up today, it's really important that we involve the public health sector. We can't expect the private sector to be very active in driving this. So here, this is one part of the public sector we find important also for IPFA, that the payers understand this plasma value chain, that they understand that in investing in the whole enterprise, you can also reach actually better treatment for your patients in your country. And especially at IPFA, what we are working on here is really that we want to see this bubble with public plasma collection to grow substantially, both in order to reduce the wastage, which we have heard very much about. Much of the plasma collected through recovered plasma is wasted nowadays, and we want that to be, of course, utilized into products, but we also want to encourage the public sector to collect really plasma for fractionation through plasmapheresis programs, which is totally possible as well. So these are typical questions we get at IPFA. How can we get access to PDMPs in our countries? We don't have enough of them. And somebody says, typical question, we have recovered plasma, we don't use it, and we want to build a fractionation plant. Can you help us? It's of course not easy to give one explanation to this. And some might say, what technology can you use to start a plasma fractionation? But I think the most important question in the end is, what is a good plasma strategy for us? Before you have the whole idea of what you want to achieve, you can't start doing bits and pieces of the others. So about finding the right plasma strategy. In our opinion, every country needs a plasma strategy. Also in countries with high healthcare status, they may need to secure the plasma collection and supply locally to mitigate the risks over the dependency of import. We have heard a lot about the imbalance of this in the world. And on the other hand, in low-income countries, there might be the first steps to be taken is to involve building quality systems and expertise into existing blood and plasma collection organizations. So a detailed plasma strategy for a country or region can vary considerably. And what is really good to realize also is that few countries can be truly independent and include all the steps of the plasma value chain. Most rely on a broader and supportive system and network. And of course, all under this, the underlying healthcare system, its capacity, its challenges and priorities, well, it has a considerable impact on the design and implementation of an appropriate strategy. So there is not one solution to a good plasma strategy, but the needs of all patients will be the best served by, in our opinion at IPFA, by a strategy which is integrated into public healthcare policies and programs. So what is being done in the world concerning this? I think many of you are familiar with the guidance that came from the WHO 2 years ago on increasing supply of plasma-derived medicines in low and middle-income countries, the so-called stepwise approach. This is a very good guidance to read. There is, I think, most of the text in it is really valuable, and of course it's heavy to read a text, so I realized that these kind of workshops helps in explaining what are the needs, that you assess the needs, you build the status of quality systems, and you look at your national regulatory systems as part of it. Then you actually are entering more in the discussion about how do you do the plasma fractionation. Another enterprise which is taking place right now is a coalition arranged by the ISBT, a working group, and it has several members, the founding members, ISBT, and then we have patient organizations, and also it's supported by the WHO. So this is also a coalition now which wants to work on this endeavor and has been very much involved in, for example, the Senegal project that Faten explained about in the previous session. So there are different ways to reach it, but I think this specific group is more looking at really the first steps of the process still to help countries with the really practical items and to implement the WHO guidances and working together with them. We are coming back a little bit to the world situation. What is it? Global plasma for fractionation. We have heard about it in previous talks. And this is also important to realize that you see the yellow line at the bottom. That's the recovered plasma, plasma from recovered blood in the world. It's just a very small part of all the plasma that is collected. And you can see the total plasma is around 60,000 liter. It was in 21. It made a dip during the pandemic. Now it's going up again. I heard from the latest figures, but we haven't received the really final ones yet. But the recovered plasma is keeping stable and even declining in some countries because the use of red blood cells in many developed countries is actually going down. So they collect less and less recovered plasma. So really, in order to fulfill the needs, source plasma or plasmapheresis plasma collection is needed for plasma derivatives. And I think this picture was also shown earlier, where the origin of plasma comes from, largely from the North America, mainly USA, and Europe, a part of it, and also the imbalance in usage of product that is really US, Europe, who uses the majority here, taken by IgG as the example. So there is really an imbalance we want to tackle and have plasma collected and made more globally, also more closely to where the products are used. There was some discussion of how many plasma fractionations there are in the world, and they are not that many. You can see that in the Middle East, Africa, here in 2020, 3 plants were mentioned, at least one of them is in Africa. And Europe has quite a lot of fractionation still from old tradition and history. Latin America is really in need of PDMPs. And the large number in Asia and Pacific is very much attributed to China, where there are several plasma fractionation. India has a few. We have in Japan, one of our IPFA members is a fractionator. And in Thailand, there is also a not-for-profit fractionator. So there are some examples. But all in all, quite a few plants. And you can understand it from these earlier presentations today, how much is needed to put up a fractionation plant. It's not something that you just build when you find the need for it and for the next year. This is a table I got permission to use from a good friend, John Curling. And he has put together what is going on in the world on some fractionation facilities, which are now either being just built or in planning. What are the capacities? And here you can see a little bit the investments in these, and they are going from 145 million in Ukraine. That plant is actually up and running, at least at this size right now, and to Turkey, where you can see that there is some sort of 600 million investment planned for a plant, which could be expandable then to 1 million liter. So you can also see from this table that these new enterprises, they really have a focus on going from, let's say, starting from smaller 200, 250,000 liter, but having the capability of going up to at least 1 million liter plasma. We also hear news on plans, and I take them always with a bit caution. Because many times when you see news like this in Australia, plant opening in 25, I say, this company has an unproven technology. There are no products yet on the market. How can they have a plant up and running in 25? Good if it works, but it sounds very ambitious. Is it a real good plan, or is it more a prospective? We also hear from Indonesia that SK Plasma wants to build a plasma fractionation plant in Indonesia. And what we have heard from Indonesia is that this is a business-to-business enterprise. The government will not take part in this investment. It will be between the provider of the plasma fractionation provider and then a local Indonesian enterprise. The plasma in Indonesia comes only from the blood establishments, from the public sector, and by law it has to be non-paid. So they will also have to trigger up their plasma collection. Today we know that the recovered plasma and the capacity is already in the order of 100,000 to 200,000 liters. So it's very possible that they can manage. But I say again, what they have said is that they want to have it built in 2 years. And well, I think most of the people who have been working with this type of plans know that that sounds very, very ambitious. So let's hope it works, but we have to take all this news with a bit of caution. They can't be directly models. You have to look behind what is behind these promises and that they announce. We heard about Egypt also earlier today, and of course I suppose that it's a country that you look at closely here as also what are they doing as a model. And we know that there is a public-private partnership between Grifols and Egyptian healthcare state actually, and planning having a 50-year contract, and with the idea to build a plasma fractionation plant of going up to 100 million liters. This has been presented publicly in meetings recently. But I've looked a little bit what they have written about it, and this is quite small figures now, but there was a picture of the clinical need and the improved treatment of PDMPs in Egypt. And I think it's a little bit along with the line of thinking that, yes, currently actually in Egypt there is a use of per capita of 2 grams per 1,000 inhabitants, which is extremely low. It's low. It was said that in Saudi Arabia it was about 17. So this is very low considering the population of Egypt, that we really can think that it suggests that there is underdiagnosis and undertreatment of patients. The factor VIII usage is better, but still it could be a little bit higher if you have a reasonable target. We did some calculations that if you have a capacity, I don't know if you can see the figure at all, it's somewhere below now here. If you have a capacity of 1 million liter fractionation, you can reach about 2 units per capita with factor 8 and 40 grams per 1,000 inhabitants for the Egyptian population. But if you again think what is a reasonable target, is it 40, or would you actually want to reach 100 grams per 1,000 inhabitants? This is a number which is taken from how you can at least treat based on PID patients, primary immunodeficiency patients, based on prevalence in other parts of the world, but maybe not diagnosed yet. So there are some questions. Will this fractionation program be accompanied by an effort to increase the diagnosis and improve treatment of Egyptian patients? Or will the plasma, which is surplus to this current, which is, we say, artificially low because we know that there are patients not treated, will they only be used for export? And who will profit from that? When will the recovered plasma from the public blood donation be used for fractionation? I've understood that there are very many different ways to collect blood in Egypt. It's complicated. But for this enterprise now, it's more a question of finding source plasma through plasma collection centers. But in my opinion, it should be also included in a country's plasma strategy, how you use the recovered plasma from the blood establishments. So there are many questions to this to be asked. And coming back to how IPFA sees the role of the public sector, and we really think that plasma for fractionation can be collected by blood establishments and not-for-profit organizations as well. Also source plasma. We see very good models in Australia, Canada, New Zealand, Italy we will hear about more, Denmark, Namibia, countries who are really thinking of how they want to do it. I'm not saying they are doing it only. There might be private enterprises also, and they might be buying other products, but at least they have put their mindset that we want to invest in this plasma fractionation value chain, and we also want to do it by collecting plasma for it. And that's again, the strategy models are very different in each of these countries. We can also discuss about the plasma fractionation by not-for-profit fractionators. There are still a few of them. It's a possibility. We don't see very many new of these enterprises coming up, and I'm not saying it's the best solution, but it might be for somebody that if you want to build this sort of plant that goes really to establish a good public health care in your country and running it on a sustainable and reasonable level. But really, also this public sector here we see as the active role of the government and the alignment between the plasma collection and the PDMP supply. For that we need policies and legal frameworks, and we need investments in the public health, whether they come from investing in the plasma collection or in the plants or in the reimbursements. All of these have to be considered. It's not just one route. We can see, for example, if we talk about Europe and a little bit what IPFA is doing right now, there are disruptions even in Europe in the supply of IgG. These figures were presented in an EMA stakeholder meeting last week, I think, or 2 weeks ago. And the curve shows how many countries have encountered disruptions in at least one IgG product per year. And it's going up really a lot since 2018. It doesn't say that the countries are without IVIG or IgG products, but it gives a signal that there are constantly disruptions. And those who have maybe ordered or a contract on one product have to find something else. So that's a problem. And that's why we are also working now in Europe IPFA is a partner in the European Supply Project, which is really intended to increase the plasma collection in Europe by the public sector. It's a project that started last year in September, and I think you should stay tuned on what is coming out of it, because there can be also recommendations used for other parts of the world. We are at least going to tell about them. Not very much has yet been published from this, because we are very in an intense working phase on this project. I think I will skip that one and come to my final slide here, just repeating, this is what we mean with supporting the public sector in every country in having a plasma strategy. Think of what you need and where you are heading before you really decide on it, and having your patients and your public health in good mind all the time. This is my last presentation, so I finish it with a nice snowy picture from Finland, where I live. Thank you very much.
Thank you very much, Leni. As we all agreed, all the questions and interaction will be in the last session. Now it is my privilege to introduce to you Dr. Ahmed Tahir al-Bahrani. Dr. Ahmed is a consultant, pathology, hematology, transfusion medicine, and stem cell production. He is the head of stem cell transplantation laboratory in King Fahd Specialized Hospital Department. He is the head of therapeutic apheresis unit, co-chairman, hospital transfusion committee, and CBA, I don't know what's this, CBA HI surveyor, perhaps you can explain it. Yes, laboratory and the blood bank. Dr. Ahmed is going to enlighten us on the plasma production for fractionation. Thank you so much, Dr. Ahmed.
Assalamu alaikum wa rahmatullahi wa barakatuh. Thank you, Dr. Faten. I would like to thank, of course, the organizer of this very important activity about the plasma fractionations, which is the future of in our country, inshallah. I would like to thank also Dr. Hand for this excellent organization, also the Ministry of Health, Dr. Maram, Dr. Nidar, and also جمعية أصدقاء بنوك الدم. My presentation, I will change a little bit the subject from the fractionation and already the plasma is collected and sent it to the manufacturer. I will focus on the primary step of the process, which is the plasma collection and the plasma production. And without this raw material, we cannot do anything, actually. We cannot start the fractionation process. So the beginning is very important, and this is the start of this project, is to collect the safe, high-quality plasma that is suitable for manufacturing. I will focus the objective in my presentation about, I will start with the introduction, some introduction, and the current global collection of plasma for fractionation, the collection method, the donor eligibility, consent, safety, storage, labeling, and summary. I think after my presentation, Dr. Hand will be able to establish in the ministry the plasma collection centers. Plasma for fractionation is a precious biological product used as a raw material to manufacture essential life-saving plasma-derived medicinal product, PDMB, which is important for the clotting factors manufacturing. The clotting factors that is available in Saudi Arabia now is all recombinant clotting factors. We don't have human-derived clotting factors, but there are some complication also with the recombinant. The rate of inhibitors is higher than the human clonic factors. Albumin, me and Dr. Hind, maybe we are the most utilizer of 5% albumin during plasma exchange procedures, immunoglobulins, the vaccines, and other type of IVIG. A lot of talk today about the IVIG. Plasma for fractionation is derived from human donors. So far, there is no replacement for human plasma. The human is the main provider of plasma. So it is collection, quality, and availability raise a lot of ethical issues, safety issue, and also scientific issue. What is the current global collection of plasma fractionation? 60% of the plasma for fractionation worldwide coming from North America, from the United States. We don't want to copy the United States experience, but we want to take the good things that they did, and we do the same. 20% coming from Europe, 14% from Asia and Oceania, and 6% from Latin America, Middle East, and Africa. My previous presentation covered this issue very nicely. PBTA, which is a plasma protein therapeutic association, reported that plasma collected from the United States donor jumped from 29 million liters in 2013 to 53 million liters in 2019. 53 million liters, imagine the number. Plasma fractionation collected from the United States donors fulfill the need of the United States totally, and also 60% of the rest of the world, including Europe. They obtain plasma mainly by plasmapheresis. It is from paid donor, and they label it exclusively for manufacturing. It is not for transfusion. This nice diagram from the BBTA, it shows how there is a huge jump in the plasma production and the plasma requirement. In 2012, the collection was only 26 million liters of plasma. In 2019, 53 million liters of plasma collected in more than 800 centers in the United States alone. Currently, as you can see, there is a drop in the plasma collection in 2020 and 2022, and you are aware about the COVID-19 pandemic that caused this drop in the donors' availability. 2021, there are more than 1,000 plasma collection centers in the state, and they collected 43 million liters of plasma. This is Europe. Also, this is the BBTA diagram. There are 153 centers in Europe, and they collected 2.8 million of plasma in 2021. Why United States is the major supplier of source plasma? At least we should get benefit from other people experience. In the United States, the plasma donation is paid donations, and they found it is effective to recruit a new donor and also to retain donors. The frequency of donation in the United States is much higher than the rest of the world. The volume of plasma that is collected is also higher than in Europe. And the plasma industry in the United States is composed of a few multinational for-profit company, which is a private company. And also they have efficient and sufficient infrastructure and resources that can cover the need of the plasma worldwide. Now, how much it is paid in the United States for every donor? They pay $35 per donation. And the donor is allowed to donate 104 times per year. The amount of money that the donor can get is $3,600 per year. If we take this in Saudi Arabia, and I think there is assumption that 150 riyal to be paid for every donor, which is around $40. So the total amount of money the donor can get in the Saudi Arabia is 15,600 Saudi riyal if he donated 104 times. Now, the paid donation in general, does it have a lot of safety issue? I think we need to study this very carefully, and I will explain in the coming slides the safety issue of paid donation. Source of plasma regulation and standards. Plasma for fractionation is collected, processed, stored, and distributed by private plasma industry, and they are all regulated, and they have a license and should be registered apheresis collection center. In Saudi Arabia, we have MOH that they give the license. We have Sibahi, which is the local accrediting body in Saudi Arabia, and all the health sector in Saudi Arabia must be accredited by Sibahi to maintain their services. We have also the Saudi FDA as well. So all these are national regulatory authority, and I believe that the Ministry of Health should be the main regulator for plasma collection and plasma safety. And all the facility also should be adherent to the GMP, the Good Manufacturing Practice. And already the Saudi FDA started to do inspection in some of the blood banks about the GMP accreditation. So far, there is no plasma collection center available in Saudi Arabia. The collection method, 85% of the plasma that is used for fractionation is collected through apheresis source plasma, and only 15% is a recovered plasma. We have also hyperimmune plasma, which is another type of plasma collection with hyperimmune donors, and for the preparation of some IgG preparations. What are the donor eligibility criteria? There are general eligibility criteria, and there are specific eligibility criteria for plasmapheresis and the plasma collection. The age should be 18 years and more. This is from the American FDA. Of course, the educational material. The weight of the donor should be more than 50. Medical assessment of the donor and the donor history questionnaire. Also, plasma should be from male and female who are not being pregnant, or female who have been tested since their most recent pregnancy and result interpreted as negative for HLA antibody. This is for Italy prevention. Recovered plasma, which form the 15% of the plasma that is collected for fractionation. Recovered plasma is either collected from whole blood donations, and the plasma will be as a byproduct from the whole blood, and usually the volume of this plasma is 220 ml, or it can be as a byproduct of a platelet pheresis collection. We collect a platelet, and also on the same time we collect plasma as concurrent plasma. So both are considered as recovered plasma, and both of them can be used for fractionation. The frequency for whole blood donation is 5 to 6 times per year, but for platelet pheresis, the donor can donate 24 times per year. The donor every time are tested for HIV, hepatitis B, hepatitis C, syphilis, HTLV1, and also in the United States tested for West Nile virus and Chagas disease. We are not testing West Nile virus and Chagas disease in Saudi Arabia because it is not prevalent. We do one additional test in Saudi Arabia, which is malaria screening test. You can see here the diagram shows us the US plasma for further manufacturing. As you can see, there is source plasma and there is recovered plasma. The source plasma is either by pheresis as byproduct or from whole blood donation. Source plasma definition. What is source plasma? Source plasma is either plasma pheresis. There is difference between the plasma pheresis and the plasma exchange. A plasma exchange is therapeutic. A plasmapheresis is collecting of a plasma. And or we call it apheresis plasma. It is collected from donor through apheresis machine. Blood is removed from the donor. Anticoagulant used for 4% sodium citrate solution. And the plasma is immediately separated by centrifugations into component. Donor plasmapheresis, it is one of the most frequent medical procedure performed in the United States. In 2019 alone, there are more than 70 million procedures done in the United States, which equal to 53 million liters of plasma. Imagine the huge number of donations per year, 70 million donations. The duration of the plasma apheresis procedure, it's variable, depend on the machine that is used, and depend on the total blood volume of the donor, and also the number of cycles that is done. Usually it's ranging from 30 minutes to 1 hour. The volume to be collected is ranging from 625 ml to 800 ml. And also this is variable, depend on the donor weight. This is the FDA recommendation. If the donor weight is between 50 kilogram and 68 kilogram, the plasma volume to be collected is 625. And if the weight is more than 79 kilogram, it is 800 ml. And this is issued in 1992, and still until now it is practiced. Consent is very important. We should take consent from the donor. It should be taken by a qualified physician. Usually it is taken on the first day of donation, and every year should be again taken. If the donor did not show for donation within 6 months, we should repeat the consent. And also if the donor is enrolled in any immunization program, we should take consent for that specific program. The consent should describe the procedure, what we are doing. It's a plasmapheresis program, and we should tell the donor that it is collected for manufacturing. We should explain the hazard to the donor, and also the risk of hemolytic transfusion reaction if the donor is given cells. Some donors, Rh negative donor, are transfused or injected with Rh positive blood to produce the anti-D. This is an example of the consent. What are the special qualifications of a plasmapheresis donor? It is the same as whole blood, as I mentioned, with a few exceptions. The donor must have a medical examination. Complete medical examination and medical history should be done on the first day of donation and repeated annually. If the donor again did not show for 6 months, the physical examination must be taken again. We have two types of source plasma or plasmapheresis. We have frequent donation and infrequent donation. The frequent donation is donation which is done more frequent than once every 4 weeks. And this type of donation, every donation is tested for HIV 1 or 2, for hepatitis B, C, including NAT, should be done. HTLV 1 and 2, West Nile virus, and Chagas disease were not tested at all. Malaria risk, which is good for us in Saudi Arabia, is not a cause of deferral. As you know, we have some endemic area in Saudi Arabia with malaria, so it is not a risk factor. And also the questionnaire doesn't include a question about the malaria risk. Also, we should do test every 4 months for syphilis. Antibody should be non-reactive to accept the plasma. Also, we should do total plasma, total protein, and serum protein should be more than 6 grams per deciliter and less than 9. Every 4 months, this one should be repeated. And serum protein electrophoresis also should be done every 4 months. already mentioned that the donor can donate 104 times per year, 2 donations in a 7 days period, and between the donation should be 2 days. The volume is up to 800 ml per donation, and the maximum volume of plasma that can be donated annually is 83 liters of plasma. The infrequent plasma pheresis, which is a donation by pheresis more than every 4 weeks, or if the volume of plasma that is collected annually is 12 liters. It is treated like a new donor with every donation and not required to do a medical history and physical examination, and not required to perform the serum protein or protein electrophoresis. This table shows us the differences between the United States and Europe in terms of the number of donations and the volume of the donation, and also the total volume of plasma collected annually. As you can see, 83 liters annually in the United States, in Germany 38 liters, in UK 15 liters annually. What is the difference between recovered plasma and source plasma for manufacturing? Recovered plasma contains lower coagulation factors, especially factor 8. Recovered plasma require longer processing time before freezing for the infectious disease testing and the component preparation. Recovered plasma contain higher ratio of anticoagulant. Recovered plasma contain higher level of cellular contamination because some of the white cells are broken down in the units, so it contains cellular contamination that may release some proteolytic enzymes affecting the stability of the coagulation factors. The source plasma contains less immunoglobulins because of the more frequent donation. But in general, both recovered plasma and source plasma are suitable for manufacturing and fractionation. Testing and the safety of the source plasma, bacteria, parasite, intracellular viruses. You know, plasma doesn't contain cells, no risk of CMV, intracellular parasite, no risk of malaria, which is intracellular parasite, so are not transmitted by plasma product because they are destroyed by freeze-thaw steps, if there are available contamination or whatever, or removed by filtration during the processing of filtrated product. Malaria risk, very important. I will focus on this one. Were not a cause of deferral at all. Now, source plasma, before to be accepted, the donor must donate at least 2 times within 6 months. So the first donation is not accepted. The second donation is not accepted. The third donation is accepted if the donor donated within 6 month period. If he did not show within 6 months, we have to, again, in the second 6 months, to repeat the cycle. This is to ensure the safety of paid donor. The storage, the plasma pheresis plasma must be frozen immediately in a temperature less than -20 within 24 hours of collection. And this is the temperature of also shipping. All plasma pheresis from paid donor must be in quarantine for a minimum of 60 calendar days before it is released for further manufacturing. This is all American FDA recommendation. In Europe, our colleague from Europe can give us also more detail about this. This is just a summary of what I mentioned. Labeling is also very important. All plasma that is collected for manufacturing should be labeled as for manufacturing use only. Also, recovered plasma, once we change from transfusion to manufacturing, the label must be changed as well. The whole process from plasma collection to manufacturing take around 1 year. This is the GMB from our Saudi FDA. We had recently had a visit from them, and they visited maybe some of the blood bank. And also in the Ministry of Health website, I found this document about a plasma collection center license. Even we don't have, what I know, there is no a plasma collection center, but I saw this document في التراخيص الطبية موجودة about the collection of plasma. The information are just general information. There are no details information about the plasma collection. And at the end of this document, there are few statements. It is written in Arabic about the plasma collection. It is mentioned here that it is not allowed to export the plasma that is collected in Saudi Arabia outside Saudi Arabia. And also it is written here that the maximum donation for every donor annually is 60 donation. So also I don't know from where this is coming. Is it taken from other country or whatever? I don't know. Also, it is mentioned that the compensation for every donation is 150 riyal. So in summary, source plasma from paid donor will continue, maybe this is against my colleague from Finland, to be the major source of plasma for fractionation for the coming years. At least in the United States, maybe in the rest of the world will be changed. Safety of the donor and donation and the quality of plasma for fractionation require a strong regulatory system that establish and enforce standard regulation and policy. At the end, both recovered plasma that is already available. We have around 700,000 whole blood donation in Saudi Arabia, and I am sure many hospitals, maybe they don't use the FFP. We can use it for fractionation. And also we need to start the business of plasma pheresis collection centers. Thank you very much.
Thank you very much, Dr. Ahmed. It was very elaborative. Thank you so much. Our next presenter, so now it's the turn of Dr. Abdul Majid Al Abdul Latif. I'm so sorry. And Dr. Abdul Majid is going to talk about the dry plasma. So can you please come and excuse me?
Assalamu alaikum. Thank you, Dr. Hind, for putting me here to present a very boring lecture today. The lectures before me, it was very informative, but my lecture it will be about historical story about dry plasma, and we will go through it, inshallah, in my presentation. Okay. So, hemorrhage is the leading cause of potential preventable deaths on the battlefield and the second leading cause of death in civilian trauma. We have a lot of problems that we want to resuscitate patients during wars or during accident when it was far away from the hospital. So those are hemorrhagic shocks will lead to the death. So we want to help for that in 2007, analysis identified that survival after traumatic hemorrhage was improved when the ratio of blood products transfused to severely wounded combat casualty approached 1:1 plasma and red blood cells as compared to lower ratio as 2 RBC to 1 plasma or 3 RBC to 1 plasma. Subsequently, reporters confirmed the importance of higher plasma ratio and showed that the primary survival benefit is achieved within the first 6 hours of injuries. In the 1930s, methods were established to lyophilize plasma as drying plasma, and successfully infuse it was reported in both experimental animals, models, and humans as well. So dry plasma was thought a valuable method for preservation to allow plasma to be transported and stored in areas where freezers were not available. Large-scale use for dry plasma began in World War II, and when millions of units were distributed to Allied forces worldwide, both in British and American, what they called military in Europe. Dry plasma yield good result in the acute treatment of traumatic hemorrhage, being most effective as bridge therapy until the oxygen carrying capacity of whole blood could be made available. So if you give the plasma, you can keep the patient alive until you have the RBCs. But why they stopped using it? Anybody can tell me. It was used very big in World War II, but they stopped it now. No. By the end of the war, it became apparent that hepatitis transmission was a problem with it. So they stopped it because they don't have the solvent detergents or the pathogen inactivation. So about the history of it, Dr. Max, he experimenting this plasma by vacuuming the plasma and dry it after that, to that he can use it in the battlefield and for civilization when they have bombs in those areas. And it was primary mode of resuscitation, combat casualty for the most of World War II, and the recognition of serum hepatitis as a result of pooled lyophilized plasma transfusion caused it to fall out of favor. It continued to be used in the Korean War, but it was abandoned altogether in 1950s. The French military continued to produce lyophilized plasma through the mid-80s. When HIV came and hit, they stopped it. Then after that, they continued when they start to have the test. So after that, they used the what they call it, the amoxicillin with the UV lights to keep the product safe. So what is lyophilization? Plasma is lyophilized by freezing under vacuum of several days and reducing water content to approximately 1% to 2% by sublimation. And the process results in a reduction in activity of some coagulation factors. In general, the changes are small, and we will see it later. The box examined changes in hemostatic parameters in lyophilized plasma by comparing the starting FFP with the lyophilized products. And then lyophilization results in change of generally less than 10% in hemostatic parameters. The most significant was the factor, von Willebrand factor. So all parameters remained in the normal range. And similar results were obtained in a study of lyophilization of atomicillin-treated pooled plasma produced. And after that, those factors remain almost the same, but it decreased a little bit. So they changed this ultraviolet treatment instead of the, what they call it, solvent detergent. Thromboelastic parameters were unchanged as well. So thrombin generation using high tissue factor reagent was unchanged, but was slightly reduced with low tissue factor, and processing conditions such as choice of plasma stabilizer can affect the presentation of or loss of the factors as well. Okay, we will talk about the history. So this is the history in 1945 when they discovered the hepatitis. Then in 1944 to 1952 as well. So after that, the French start continuing to use it after that. But when the HIV came, they stopped it, and they resumed doing that after the solvent detergent. So about the modern lyophilized plasma, the end of the significant use of dried plasma was largely attributed to inability of ensure the safety of pooled plasma, and not because of failure with the drying process or the physical characteristics. In the early 1990s, reliable pathogen reduction method became available. New technology for pathogen reduction and improved methods for screening enabled the development of dried plasma with dramatically improved safety and profiles. The later development of nucleic acid and other pathogen testing method further contribute to safety of today's dried plasma product. And the current product now excludes plasma from women with anti-human leukocyte antigen antibodies and incorporates pathogen reduction using an amoxicillin and ultraviolet. This product has been used extensively with an excellent safety records. These products are currently available within each respective country and limited others. Incidence of transfusion reaction were similar for lyophilized plasma and FFP, and successful use of lyophilized plasma has been reported for both military and civilian emergency medical application. The Norwegian Helicopter Emergency Medical Service published in 16 patient cases serious with lyophilized plasma. No transfusion-related complications were recorded. There were 2 deaths at the scene of injury, and the other 14 patients survived. Each report conclude that use of lyophilized plasma was feasible in external and pre-hospital settings. Prospective single-blinded consecutive enrollment trial compared with efficacy and safety of dry plasma to non-solvent detergent-treated single donor lyophilized. So they like using the ultraviolet with atomicillin better than SD. So this is a compare between the FFP and lyophilized plasma. If you see the range is in the first, and in the middle of the FFP, and the third is the dry plasma, and there's only a few change or a small change between the factors that it will affect during drying. So this is the process of manufacturing the dry plasma, and all are sterile filtration going through with Octaplast LG Lyo. This is a new what they call improved of the ultraviolet with amoxicillin. It is now, it's FDA approved, and it was shown on 2018 in USA. So what is the benefit of early plasma transfusion? So plasma gives more time to get whole blood, or by using damage control resuscitation treatment into the patient. And multiple use large center retrospective cohorts showed 24 to 28% of severely injured trauma patients are found to be coagulopathic on admission. It has neuroprotective effects in traumatic brain injuries that it will improve 50% of those patients. So what is the therapeutic indication? Complex deficiency of coagulation, factors such as coagulopathy due to severe hepatic failure or massive transfusion, substitutional therapy in coagulation, factor deficiency when a specific coagulation factor, concentrate factor 5 or factor 11, is not available. Rapid reservoir of the effective oral anticoagulant as well. A potentially dangerous hemorrhagic during fibrinolytic therapy using tissue plasminogen activators in patients who fail to respond to conventional measures. And therapeutic plasma exchange procedure, including those in thrombocytopenic purpura. So this is a big, huge, program from the French dry plasma. They made in 2017. It was a very huge study about the dry plasma itself. So this is the history of using the dry plasma. It was in bottles like this, and it is like a powder, the dried antibiotics for kids that you can use it. It is the same thing. However, this will help in hemorrhagical shock. So it will reconstruction time is less than 6 minutes, 2 years shelf life, storage from 4 plus to 25 at a room temperature, or in the fridge, inactivated by a methicillin process, liquid-reduced, and all controls are done by bottle and batch production. Therapeutic plasma monitored by the active French hemovigilance and specific traceability. And it's coming soon. For them, it's a 3 years shelf life. So if you see here, there's in the remote areas, like inside the tent between 0 and 15, outside between 28 and 53, and on the pack bag, for example, between 20 and 50, and in the refrigerators in 4 Celsius, and in the room is 18 to 38. So they use it in the battlefield in here, and they show it in role 1, 2, 3, and 4, and they use the helicopters and airplanes and ships as well. So at the Military Medical Center in Toulon, they retrospectively studied between 2012 and 2015 the primary objective to compare the time frame between the dry plasma and fresh frozen plasma, and the secondary objective to compare the volume transfused and mortality within 24 hours, and inclusion criteria trauma patient who received 2 packed RBC in the emergency room. So they did it in 72 patients, and no significant difference between age, hemoglobin, platelets count, and reticulocyte lactate, and within 24 hours, and the mortality, and the significant difference delivery time frame, number of packed RBCs, and time to reach 1-to-1 ratio. So those are who did this study. So one of the studies done was published in Transfusion magazine. It's about frozen and freeze-dried solvent detergent treated plasma, 2 different pharmaceutical formulations with comparable quality. And the conclusion was it's almost the same. However, the speed of using the dry plasma is the winner for that. And there's another study, use of dried plasma in pre-hospital and austere environments. And he showed that that the fast of using this dry plasma is superior to fresh frozen plasma because it is very easy to handle it, and it will be in the cars or in the backpack bag of the military soldier. And one of the study as well is the dry plasma state of science and recent development, which shows as well that dried plasma product with reduced logistics requirement is needed to enable plasma transfusion where they're medically needed. And it was, as well, it is very, very effective. So in conclusion, the early transfusion of plasma is important to ensure optimal survival of patients with traumatic hemorrhage. In military and remote or austere civilian settings, it may be impossible to move patients to hospital facilities with the first few hours of injury. And a dry plasma product with reduced logistical requirement is needed to enable plasma transfusion where medically needed, instead of only where freezers and other equipment are available. And historical dry plasma products solved the logistics problem, but were abandoned because of the disease transmission. Modern methods to improve blood safety have made it possible to produce safe and effective dry plasma. Dry plasma products are available in France, Germany, Sweden, and South Africa, and a limited number of other countries. Although challenges exist, the in vitro and in vivo data suggest that these products have great potential to be safe and effective. So in the end, dry plasma provides an alternative for early plasma transfusion in the resuscitation of hemorrhagic shock in an environment where fresh frozen plasma is not immediately available, and it is easy to store, transport, reconstitute, and administer. This is the reference, and thank you so much.
Thank you so much, Dr. Abdelmajid. That was really very informative. And I have to make it up for you because I really didn't introduce you properly. Dr. Abdelmajid is a transfusion medicine consultant in the Directorate of Laboratories and Blood Banks in the Ministry of Health of Saudi Arabia. He is also the medical supervisor in the COVID-19 laboratory in Riyadh Regional Laboratory, and blood bank medical director and consultant in the Central Blood Bank Riyadh Regional Laboratory. Thank you so much. And now we are going to break for the coffee, only 15 minutes, and then come back for the last session. But we have a very important announcement that the organizers are inviting all of you for a very, very nice tour and dinner. The tour starts exactly at 5:30 in the lobby of the hotel. So please, after the last session, we can go to our rooms, change, and get down. And it will be in the Kingdom Tower and Sky Bridge at Kingdom Tower. Visit Al Bujairi Park in Riyadh. Sorry for my pronunciation. Visit Al-Daraya and have a dinner. And it will be, we were promised it will be very nice. So now we pause for only 15 minutes and then come back, please, after 15 minutes. Thank you so much.